Welcome to FPGA Design for Embedded Systems. The objectives of this class are to acquire proficiency designing digital circuits with field programmable gate arrays, FPGAs, employ industry standard tools to design, implement programmable logic solutions, and several hardware description language design entry methodologies, including VHDL, Verilog, and System Verilog, and build proficiency by designing basic digital programmable logic circuits in VHDL, Verilog, and System Verilog. As a recap, here's a flow of the FPGA design process. Design entry, schematic or HDL, proceeding to functional simulation, synthesis and mapping, place and route or fitting, timing analysis and timing simulation, and then programming the device and then testing the device in your system. And today we'll look at the differences between schematic or hardware descriptive language design entries. In schematic entry, we have logical correlation between schematic design and the circuit implementation, which is not always transferable between different FPGA tools and technologies. So if we take this AND gate or OR gate drawn out inside of the schematic in the design tool, it's difficult to translate that into other design tools, unlike hardware descriptive languages. And it's also difficult to scale for larger designs. If we have a multi-million gate design, it would be difficult to look at the entire design scope as AND gates and OR gates. If we look at hardware descriptive languages, VHDL, Verilog, or System Verilog, we can see that it's compact and transferable. Since this is a text file, we can email this or save it as part of our design archive. Hardware descriptive language key concepts. Describing a hardware circuit implementation that your tool chain will eventually interpret and synthesize into FPGA logic cells. So whether it's schematic-based or hardware descriptive language-based, the tool has the ability to synthesize this description into logic cells. Hardware descriptive languages are concurrent, not sequential. FPGA logic cells are hardware and inherently execute in parallel, whereas CPU code running on a microprocessor is software and inherently executes in sequence from top to bottom. In summary, we've reviewed the FPGA design flow, explored FPGA design entry options, and introduced the key concepts of using hardware descriptive languages, HDLs, to describe circuit implementations.